Hi Marilyn, I figured this would be easier to answer with with a video than with an email, so hopefully this will work out for you. Um, Using a graphing calculator, it says graph this function, and then find the intervals in which the function is increasing or decreasing. Um, so the problem seemed to me to be actually getting a graph of this thing going. I would show you how to do it on a graphing calculator, but I don't have one on my computer that I can record for you. So I'm going to show you another method. I'm going to bring you to this website called wolframalpha.com. You can see how to spell, if you can't see the little letters up here, you can see how to spell Wolfram Alpha right here. It's just that.com with no spaces or anything like that. So it's a really nice website because you can ask it all kinds of questions. And in this case, we just want to graph. Let's see what the function is. We want to graph this function. And this is in the viewing rectangle. And when it says in this viewing rectangle, what that means is -3 to 7 are the x values that you want to graph it in. And then the y values will be -20 to 15. I'm not sure if Wolfram Alpha gets that specific, but what you can tell it to do is graph it from x equals -3 to x equals 7. It's pretty easy to do. So I might have to go back and forth a couple of times. So I'm going to type in this function. I'm going to say graph this, and I'm just going to type that in. -x cubed plus 6x squared minus 9x minus 6. And we're going to graph that from -3 to 7. And Wolfram Alpha will automatically know that means x. Okay, let's try it. I'm just going to type in graph. I believe it was -x. The way you write cubed is with a caret 3. And I think it was plus 6x squared. I'll go back and correct it if it's not right. And I think it might have been plus 9x plus 6. That's probably wrong, so let's fix that. -x cubed plus 6x squared minus 9x minus 6. So this should be a minus 9x minus 6. And you can see that the minus is just sort of the dash. And we're going to graph that from, I believe it was -3 to 7. Let's see if that's right. Yeah, -3 to 7. We're giving the x values here that are in that box. So if we do this, I haven't actually done it yet, but hopefully this will give you a really nice graph. I just hit enter. Alright, I'm going to scroll down here, and you get a pretty decent graph. So it's not really ideal. I was kind of hoping for something a little better than this. The key here is recognizing that your function decreases everywhere that I'm pointing at right now until you get to this little minimum value. It's called a local minimum. Then the function increases to this local maximum, and then it decreases all the way off to infinity. So the key to answering this question is now going to be, how can we find this value of this point right here, and how can we find this value of this point right here? If we can do that, then we have all of the information that we need. There's a couple different ways to get around this. One thing that you could do is just graph this function in the area that you're interested in. So we have it graphed from -3 to 7, you'll see. We don't need it from -3 to 7 though, because we don't need to know any of this information out here. We don't need to know any of this information over here. We can kind of tell what happens just by looking at this graph. So what we really want to do is we want to zoom in on this graph, maybe between 0 and I would say 4. So we can change this up here. We can change this to graphing between the x values of 0 and 4. And maybe that will give us a graph that's a little more helpful to us. Okay, so scroll down here and you can see what this graph looks like. This is actually a much better graph for you. It looks to me like this graph has a local maximum right here at x equals 3 and y equals -6. And it also looks to me like this graph has a local minimum right here. It looks like x equals 1 and y equals -10. Now, if you're not quite sure what these values are, and you're looking for what these exact values are, so to me, maybe that was just an estimate, what I just said. If you want to confirm what those exact values are of the local minimum and the local maximum of this function, there's a way you can do that as well. All you have to do, I'm going to go up here and I'm just going to change this to find the local minimum of that function. And you don't need this in here. And that should immediately pop out. We're thinking a number like x equals 1 and y equals negative 10. Let's see if it does. I hit enter there. And what do we get? Yes, the result is the function equals negative 10 and the x value is 1. And it gives you that point right here. X equals 1, y equals negative 10. So we were right. And you could similarly type and find the local maximum of this thing. And then you have all the information you need to go back and answer this question. So find the intervals on which the function is increasing. Well, the function increases. Let me go back to our original graph if I can find it here. Here it is. We found that our function increases only between this value and this value. And I saw in your email a pretty common mistake. The way that we report the values is we give the x values. The function increases from x equals 1 all the way up to x equals 3. I believe you said something about negative 10 to negative 6. That's not how we report where the function is increasing. The function increases from 1 to 3. X equals 1 to x equals 3. So the correct answer here would be 1 to 3. So hopefully that'll get you started and you can do the rest of the problem. Hopefully not have too many issues. But let me know if you do, and let me know if you have any other questions.